Welcome to video E36, tree diagrams and the counting principle. Got two examples. Let's get right to it. Tree diagram. So a coin is flipped, and when we flip it, it could have heads or tails. And then after that, a die is rolled. And it could be 1, 2, 3, 4, 5, or 6. All right, so this is a tree diagram. The first event is tossing the coin. It could be heads or tails. And then after each one of those events, we roll the die, and it could be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So notice the possible outcomes are heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. And that's summarized in the outcome column. All right, here we go. How many outcomes total are there? And once we get to the counting principle, I'll show you a shortcut. For right now, we'll just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So you're just counting. How many outcomes have tails and an even number? Well, I'm just going to look here. Tails and an even number, right there, and right there. So that would be 3 of them. Hopefully we know 0, 2, 4, 6, 8, 10 are the evens. So once again, there's 3 of those. And finally, how many outcomes have a 5 or a 6? All right, so I don't care what the coin is, just I want to have a 5 or a 6. So you've got a 5, you've got a 6, you've got a 5, you've got a 6. So it looks like there's 4 of those. Okay, that wasn't too bad. Counting principle. If there are m ways to do one thing and n ways to do another thing, then there are m times n ways to do both things. In other words, you just multiply. So here's an example. Mr. Olson must choose a clean shirt and a clean pair of pants for an outfit. Okay. He only has 3 clean shirts and 2 clean pairs of pants. All right, the laundry's been a little bit behind. How many different outfits can Mr. Olson make? And just to make it be more fun, I brought out some of the clean shirts and some of the clean pants, although not anymore. All right, well, why don't you use the counting principle? There's 3 ways of doing this and 2 ways of doing this. I like to make little blanks. So for each event, this will be the shirts event, and this will be the pants event. And then I like to put how many ways of doing each event. Shirts, there's 3 ways of doing that. Pants, there's 2 ways of doing that. So I multiply 3 times 2, and I get 6. So I can make 6 total outfits from those shirts and pants. Getting back to this tree diagram, I could have found the total outcomes without having to count them all. Look at this. There's 2 ways of tossing a coin, and there's 6 ways of rolling a die. So 2 times 6 equals 12, and that's exactly how many outcomes we had there. And then just in closing, something that me and Mr. Manasano want to get across to you. All we are saying is give probability a chance. And that's what this unit's about. So there you have it, tree diagrams and counting principles.